Hello, I'm very pleased to be with you here today. We're part of the Sunspace Art team, and we combine science and art together to do creative activities. Now, I'm a solar scientist, and I'm going to tell you a little bit about the sun and what I've learned about the sun. And then afterwards, Helen is going to do some art activities with you. So Helen, would you like to tell us a little bit about yourself?
Yes, hello, my name's Helen Schell, Helen as well, and I'm an artist and I specialise in work about space science. So this workshop today, we're going to learn how to make solar pop-up cards, and you're going to do some research and you're going to learn about the sun, and you're going to use this to make your cards.
So we hope that you enjoy this workshop, learn something about the sun from it, and also try out some of those pop-up cards. And there are lots of other activities you can try as well later on. So now we'll have a little science discussion first of all. My name is Helen Mason, and I study the sun. I work at the University of Cambridge. I've studied the sun for many, many years. I've worked with NASA, the space agency in the USA, and with ESA, the European Space Agency, on solar satellites. So today I'm going to share with you some of the things that I've learned about the sun and also tell you why I'm so passionate about it. This image you can see here is taken from the Solar Dynamics Observatory, which is a spacecraft studying the sun. On the right-hand side of the image, you can see a huge explosion on the sun. Now, sometimes the sun is very quiet and sometimes it's very active, and it has huge explosions and solar flares on it. So let me tell you a little bit more about the sun. The sun is our star. It's like many of the other stars that you see in the sky, but it's our special star and it's very close, so we can see it in a lot of detail. It's a middle-aged star. It's about 4.5 billion years old, and it's going to take about 6 billion years, and then it's going to grow into a red giant and expand outwards. And eventually the atmosphere will explode off in what we call a planetary nebula, and it'll be left with a little white dwarf in the center. Now the sun is huge, and here you can see an image of the sun, and you can see some dark spots on it. These are called sunspots, and they indicate how active the sun is. When there's a lot of sunspots, the sun is very active. There's lots of explosions. When there's hardly any sunspots, the sun is very sleepy and quiet. And that cycle of activity is about 11 years. So at the moment, the sun is very quiet and sleepy, and there's not much explosions happening on it. The sun gives us life here on Earth. Without it, we could not live. It gives us light, it gives us warmth, it gives us energy. It gives us almost all the energy we have here on Earth came originally from the sun. It's huge, with a radius of about 700,000 kilometers. So that if you see that these little sunspots, you see that small one there, near the center of the sun, that's about the size of the Earth. You could fit over 100 Earths across the sun and about 1 million Earths inside the sun. So the sun is huge compared to the size of the Earth. It's a long way away, and it takes light, which travels very fast, just over 8 minutes to reach us from the sun. So the sunlight you see now would have started its journey about 8 minutes and 20 seconds ago. The surface of the sun is around about 6,000 degrees. The core is much hotter. The core is at 15 million degrees. So in the core of the sun, it's very, very hot, as I said. The hydrogen turns into helium, and that gives us energy. The helium is just a little bit less massive than the hydrogen it's made up from. And that mass turns into energy according to Einstein's very famous equation, E = mc², where c is the speed of light. So a small amount of mass turns into a huge amount of energy. And that's the way in which energy is produced in all the other stars. Now, that energy travels out from the core. It takes quite a long time to get through a zone we call the radiative zone. And then just beneath the surface, the energy is transferred by convection. So the energy is moved from inside the sun to the surface of the sun. So here we can see a sun with a lot of sunspots on it. And as I said, when there's a lot of sunspots, then we get a lot of activity. And that activity and those explosions that take place on the sun can sometimes reach as far as the Earth. And when they do, they can give us beautiful effects like the Northern Lights. Now, I've never seen the Northern Lights. I'd love to see them. But they can be pink, they can be green. They're called aurora. That's the scientific name. Aurora borealis for the north, aurora australis in the south. And here you can see the sun is spinning. And the sun spins around. It takes about 25 days at the equator to spin around once. Now, Galileo is one of my very favorite scientists. He lived in Italy. And there you can see a view from his window. Now, he was very controversial. He said things that other people didn't believe were true about science. He asked questions about the science. And he used a telescope to look at the moon and the planets. And he decided from his observations that the Earth goes around the sun. Now, I'm sure that you've learned that the Earth goes around the sun. And now you'll think, well, why did anybody think that the sun goes around the Earth? Which is what they used to think. Because they thought the Earth was so important that everything would have to revolve around it. But Galileo said, no, actually, I believe, and it confirmed what Copernicus had said, that the Earth goes around the sun and the other planets go around the sun. And because of this, he was kept under house arrest, a little bit like the lockdowns that we've been having recently. He was kept in his house in Italy, and this is a view from his window in Tuscany, a beautiful part of Italy. Now, besides studying the planets and the moon, Galileo also studied the sun. And this is when I tell you, you must never look at the sun. The sun is too bright and it can damage your eyes. Galileo used his telescope to project an image of the sun, and then he drew what he saw. And these are his drawings. And you can see the sunspots there. He saw the sunspots. And he also saw that the sun was spinning, as I said, taking 25 days to spin around on its axis. Now, today we have some really good telescopes that we can use to study the sun. Special solar telescopes, as I say, you never look in the telescope at the sun. You use a special solar telescope or you project an image. But this is a very new telescope, which is in Hawaii, and it's called Decast. You can see the surface of the sun, that convection just beneath the surface, like porridge bubbling on a cooker. You can see the convection cells. This is the most detailed image we have of the surface of the sun. And each of those little cells is about the size of France. It's huge. Now, many of you might know what this is. This is a total eclipse of the sun. That is when the moon goes between the Earth and the sun. And the moon exactly blocks out the disk of the sun. Now, the moon isn't as big as the sun. The moon isn't as big as the Earth. But the moon is much closer to the Earth than the sun. So although it's much smaller, it's able to block out the sun exactly because it's very close to the Earth. Now, the disk of the sun is 1,000,000 times brighter than this ring that we see during a total eclipse of the sun. This is called a crown of light or a corona. Corona means crown of light, and it's very, very beautiful to see it. It only lasts a few minutes, but it's just amazing to see it. And you can see there a lot of structure. It's not smooth, it's got a lot of structure. And that's because that corona that we see is 1,000,000 degrees hot, very, very hot. Now, I said the surface of the sun was about 6,000 degrees. But this atmosphere of the sun, this corona, is 1,000,000 degrees. And that's one of the things we as scientists have been trying to understand. And you can see a lot of structure there. Because the gas is so hot, it's charged. And because it's charged, it traces out the magnetic field on the sun. So the sun has a magnetic field, just like the earth has a magnetic field. And you use a compass to get around on the earth. So the sun also has a magnetic field, and we can see it traced out. It can be very frightening during a total eclipse because we depend so much on the sun. If the sun goes out, it's very frightening. It goes dark, it goes cold. And in the olden days, people didn't know what was happening. I know what's happening, and scientists know what's happening, and people will know what's happening now. We understand it a little more. But here you can see the Cherokee Indians. I was here in America for an eclipse in 2017, and then I was in a place called the Great Smoky Mountains National Park. And the Cherokee Indians lived there. And in the olden days, they used to think that a giant frog was eating the sun. It sounds silly to us now, but when people don't understand, then they build up stories as to what they think might be happening. It was a beautiful location to be. We were high up in the mountains, and all around us, when they had the total eclipse, we saw a pinky sky, like a sunset or a sunrise. Very, very beautiful. Now, here's another of my very favorite scientists, Sir Isaac Newton. And he's a favorite, partly because he lived in Cambridge, where I work, but also because he was very clever at many things. He was clever at mathematics. He was interested in astronomy, and he built his own telescope himself. He built it out of mirrors. He, of course, worked out the laws of gravity by just asking a very simple question. Why did that apple fall down? Why didn't the apple go up? Why didn't it stay where it was? And by asking that very simple question, he was able to work out the laws of gravity that tell us all about the behavior of us here on Earth and how the planets go around the sun and many, many things. But he also was very interested in light. And he was interested in finding out about the colors of light. And if any of you have ever seen a rainbow in the sky, you probably know that if the sun's behind you and some raindrops in front of you, then you get this beautiful rainbow effect. Now, what we call visible light, or light that our eyes can see, can be broken up into these colors, the colors of the rainbow. So our eyes can see all of these colors. We also call that white light or visible light. But actually, there's a lot of radiation that comes from the sun beyond that which we can see, but we can detect it in other ways with special cameras, or in fact, there's something called ultraviolet light which comes through, which we have to be very careful about because that can damage our skin. So we have to put sun lotion or sunblocker on our skin to protect ourselves. Or we have to put sunglasses to protect us from the brightness of the sunlight, but also the ultraviolet radiation. So you'll see on the sunglasses, it says UV protection. Now, when we do some workshops in schools, we use some things called UV beads. Now, these look very boring indoors. They're just a white color, and you can make a bracelet out of them, or bookmarks or things like that. But actually, if you take them outside in the sunlight, or even when it's not shining brightly, they will change color and you will see the colors. Then you take them indoors again and they'll go dark again. Or you could use a special UV light to show this effect. They're great fun to work with and to understand how strong. The stronger the sunlight, the deeper the colors go. Now, this is a picture of the sun taken with a special camera. This camera can see X-ray radiation. You might have heard of X-ray radiation. Our eyes can't see X-ray radiation. Our eyes can't see ultraviolet radiation. Our eyes can only see the visible, or the colors in the visible. But this camera on a satellite called Yoko, which was a Japanese satellite, took a picture of the sun in X-rays. The camera was able to take a picture in X-ray, but in order to see it, we have to colour it. So we've coloured it orange because we always think of the sun as a sort of orangey colour, where actually the sun is actually white and it looks orange coming through our atmosphere. But anyway, we've used orange here to colour it in. And you'll see that it looks very strange. And what we're seeing here is that very hot corona, that crown around the sun, that crown of the solar atmosphere. And it was 1,000,000 degrees, very, very hot. And because it's so hot, it shines brightly in the ultraviolet and in the X-rays. And you can see some strange features here on this picture. You can see a very dark region up the top here, and that's where the corona has flown out into space. It's evaporated into space, into what we call the solar wind, which flows off the sun. And here in the middle region, there's some very bright regions, and these are regions where our sunspots are, where the magnetic field is very strong, where the magnetic field is popping out from beneath the surface and back in again. And the magnetic field is trapping that very hot gas, that hot charged gas, which the scientific name we have is plasma. That's a scientific name, but it's very hot gas which is charged. So we've used satellites to look at the sun. And this is one of the satellites I've worked a lot with, even before it was launched. And it's been launched more than 20 years ago. As I said, I'm very old now, and I've worked on a lot of different satellites, from Skylab through to Solar Maximum mission, through to SOHO, to more recent satellites. Too many for me to mention. But SOHO was a really excellent satellite because it looked at many different aspects of the sun, and it had lots of different instruments, and all the teams have to work together. So in our work, we don't just work on our own. We work with a team of people with different expertise, some engineers, some who know about computing, some who are scientists, and we all work together to try and to build the instruments first of all, and the satellites, and then to instruct them and to get the data back and to analyze it and to work together to understand what we're seeing. So SOHO was launched a long time ago in 1995, but it's still operating, it still works. Some of the instruments, we have better instruments now, so we don't use those instruments on SOHO anymore, but some of them we still use. So it was very exciting when it was launched. It was operated from over in the USA, in the Goddard Space Flight Center, NASA, Goddard Space Flight Center, where I worked with the teams over there to get the observations. So it is in a strange orbit. Most satellites orbit around the Earth, but actually SOHO orbits around the sun, and it goes around the sun with the Earth at about 100th of the distance between the Earth and the sun. And that means it sees the sun all the time, so the Earth doesn't get in the way. I think it's the best satellite we've ever had, but we do have many more recent satellites which give us great information about the sun. So this is one of the images or movies from SOHO, and this is taken with a camera which can see this ultraviolet, this UV light. Now, as I said, our eyes cannot see ultraviolet light, so we have to colour these images taken with this special camera, and in this case we've coloured them green. Sometimes we colour them pink or purple or blue. This one's coloured green so we can see it. The sun isn't really green, we know that, but this is a picture in an image taken in the ultraviolet, and you can see those dark regions again where the solar corona flows out into the solar wind, into space, and you can see lots of bright regions and lots of regions where the sunspots are flashing. When I first saw this image on a screen at the Goddard Space Flight Center, I was just stunned. Every time I was just stunned. It looked like little diamonds sparkling all over the sun. I had never seen anything like it before. Every time we get a new instrument and we see more detail of the sun, it is just amazing for us because the sun is just fascinating. Now there's another instrument on SOHO where we can see explosions that come off the sun. Now the sun is blocked out a little bit like an eclipse, and where this ring is, this white ring, that's where the sun is behind, it's blocked out. And this, because the sun is very bright, we have to block it out so we can see this fainter explosions shooting out from the sun. We call this a very big name, coronal mass ejections. We call it CME for short. It's just an explosion of material shooting out from the sun. And billions of tons of material moving with speeds of up to 2,000 kilometers per second, very, very fast, shooting out from the sun. And here's a movie which shows you this material lifting off from the sun. The sun's been superimposed. It's really been blocked out, but we're showing you what it looks like. And if you watch carefully, you can see it lifting off and then shooting out into space. Now, sometimes these can shoot out in different directions, and we're not really worried. We want to understand what causes them. We want to understand everything about them. But sometimes they can shoot towards us here on Earth. And then we do get worried because this material from the sun shoots towards the Earth. Now, this picture here on the left-hand side isn't to scale. This is the sun, and here's the Earth. The Earth is really much smaller, as I told you. But the material can shoot out from the sun, and fortunately, our Earth is protected by its own magnetic field, and this just illustrates it. But it has a blanket protecting it. So when material shoots out, quite often it will just scoot around the edge and it won't trouble us too much. But sometimes it can shoot out like a shock, can hit it like a big wave coming. It'll hit it, and it'll hit the Earth's environment, the magnetic field protecting it. And then what will happen is that the Earth's environment will change very suddenly, and particles will shoot back down towards the polar regions. And those very fast particles will interact with the atoms in the Earth's atmosphere, get them very excited, and they get excited, and then they emit light, the pink light and the green light of the aurora. And that's why we have those lights up in the northern regions, polar regions, and the southern polar regions. And here's a beautiful picture taken from the northern regions there. And below you can see a picture of an art that was done by one of the children during the workshops that we had of the aurora. Very beautiful picture. So these explosions on the sun, these solar flares or these ejections, coronal mass ejections, CMEs, which shoot out from the sun, can cause aurora. Beautiful effects and very good to see. But they can also damage satellites. They can harm humans if they're in space on a spacewalk or traveling somewhere or on the moon or on Mars. They can cause electricity blackouts. They can affect polar flights across the poles. Because we live in such an era when we depend so much on technology, these effects can be very harmful to the Earth's environment and to us here on Earth, in the sense of affecting our phones or our GPS and things like that, or knocking out our electricity. We call this the effect the sun has on the Earth a space weather effect. So just like we predict the weather here on Earth, we can predict what effect the sun is going to have, whether there's been one of these explosions, whether it's coming towards us, whether it's going to affect us. So space weather is a very important area of research for us to understand the interaction between the sun and the Earth. This is Tim Peake here, and he went up in the International Space Station a few years ago now. He was up there for about 6 months, and he was very fortunate and very happy to have done a spacewalk. And he did the spacewalk in order to repair those solar panels, which actually give the electricity to the International Space Station. But before he did that spacewalk, he needed to check with the solar scientists to make sure there weren't going to be any storms that might affect him and give him a dose of radiation. While he was up on the International Space Station, he was also fortunate to see many aurora. It's one of the things he really wanted to see, and he was able to see and produce some beautiful photos and movies of the aurora. So we have 2 satellites which were recently launched, which are going very close to the sun. Now they have to be specially protected. Often people ask how close you can get to the sun. Of course it gets very hot. So these satellites have to have a special heat shields on the front to protect the instruments from the heat that comes from the sun. But Parker Solar Probe, NASA's Parker Solar Probe, has been up for a couple of years now and is going very close to the sun. And it's sampling that solar wind that flows off the sun. ESA, European Space Agency's solar orbiter, was launched earlier this year. And it's not going quite as close, but it has some instruments which were used to study the sun, to look at the sun in different wavelengths, in the ultraviolet wavelengths, and also to sample the solar wind and to try and understand better. So the idea is to understand better the link between the sun, the solar wind, and the Earth. Now, just after Solar Orbiter was launched, unfortunately, most of the world went into lockdown with COVID-19, and all the instruments had to be tested out just from people's houses using Zoom, just like I'm using now. But they managed to test all the instruments and make sure they're all working and give some first results. So if you go onto the ESA website, you'll see some first results from Solar Orbiter. It was amazing that they did it all in time, working as a team together. So it's amazing what you can do just from home. So finally, I just wanted to say that we work together with schools and museums around the country. We've run many, many workshops, and we'll learn a little bit more about the art activities from Helen Schell. But what we do is bring together a team of artists and scientists. We have about 10 people on the team, and we run workshops which introduce some science topics, that's solar topics, or solar system, or space travel, human space travel, moon, Mars, and then we do some activities which develops creativity and reinforces the science that's being learned, but also expresses in a very creative way. So thank you very much for listening today. It's been a pleasure to talk to you.
Hello, my name is Helen Schell and I'm a visual artist. I make art about space science. I love everything to do with space and find it really inspiring. And this session is to help you use art and science together. So you have just seen a really amazing PowerPoint that shows you fantastic images of the sun to inspire you too. And you've heard lots of sun facts. So this is what I would use to make my art. I have made very big artworks about the sun, and I also make a lot of works about the moon. If you want to see images of my work, you can always Google me, Helen Schell, Artist UK, and get some more inspiration. So I started doing work about space about 12 years ago, and I've done work with universities and I work with scientists. Also, I've been really lucky and I have gone to NASA and ESA, where I've met scientists, and sometimes I even get to meet astronauts, which is wonderful for me. And I ask them really difficult questions, and then I would take that information and I will make some huge artwork from it. I like to draw rockets, but I also like to do images of the moon, and especially for this workshop, I love to do things about the sun. I usually use acrylic paints on canvas, but I also make collages using paper. So I hope it all goes really well for you. And I want you to do plenty of research, as I always do plenty of research. Hello, my name is Helen Schell, and I'm an artist who works for the SunSpaceArt team, where artists and scientists work together. SunSpaceArt is a project which uses arts and crafts to teach space science to schools, children and families. It is funded by the STFC, which is the Science and Technologies Facilities Council. Today's activity is how to make a solar pop-up card, which should take 1 to 2 hours with research, preparation, making it, and a show and tell at the end. You will need to find out about the sun and the solar system from websites and books. The SunSpaceArt website has lots of information and resources, and so does NASA, the American Space Agency, and ESA, the European Space Agency, where you can download images and space science facts. I would ask that you look, invent, make and recycle. Remember, if you use recycled objects, please ask an adult first.
The other thing I should mention is that you should never look directly at the sun as it harms the eyes. If you go to the STFC website, you will find that there are some really good space resources which you can order. You can either get actual books and posters, or you can just download them from the website. And remember, you can always go to your local library to get books about space. I'm going to show you how to make a solar pop-up card. So here's some of the boxes that I have where I collect up materials which I can then use to make art. Firstly, I have felt tip pens and pencils. Now you can use paints for this workshop as well. You will need some bits of cardboard and some coloured papers. Sometimes I use old wrapping paper and old photographs, and I just look for really interesting things to include. I also have a box of circles. We're going to use them because we're going to do stuff about the sun and planets. And I've got some strips where I'm going to make some objects. You will need some paper and some card. Choose some coloured paper and card, but you can also have white paper if you like it. I also use scissors, glue sticks, sellotape, and double-sided sticky pads. I collect things that are circular so I can use them to draw around and make my planets and my sun. So look around. If you have things that you can reuse, then do that. Now don't worry if you don't have all of these things. You can use what you have around you and make the best of it. This is a variation on what I'm going to show you today. What we have is something that opens up and moves, and you can have fold down bits and it changes its appearance. To make our pop-up card, we need to use folding, cutting and collage techniques. So I'm going to show you how to make a basic card, and then you can add in your own creative parts. Now remember, I want you to write some facts about the sun, and you'll need to do your research. So you take an A4 sheet of card, fold it in half, like that, and make it nice and neat, and then fold it in half again. And then when you've done that, open it up again, and take your ruler, and take a pencil or a pen, and then we're going to draw a line across from the center fold to the first fold that you did. And we draw another one, make them nice and straight, and then you can see, so we've got, this is your center fold, and that's the second fold that you did. Okay, so we take our scissors and we really concentrate on this and cut a really nice straight line. Open it up like that, and you can fold back that one, and then you have your cutout bit there, and so you pop that through like that, and there you already have a really good pop-up card. Now of course that's not enough, we need to decorate it. I'm going to stick a couple of suns onto mine, and then it'll be ready to write some sun facts on it. So I found these really nice bits. I have a lovely bit of holographic gold paper. I also have these which I brought from a discount store, and I'm going to get my glue and put it on in the middle of that one, stick that down on top of it, and that makes a little sun shape to me. It's got all its fiery bits coming off it. I found this is a bit of old wrapping paper. I'm going to stick it on the middle of that, and there we have a little sun. So I take my card, and I've got to decide where I would like to put that. So I'm going to put a bit of glue on the back of that. So already I've got a fantastically bold design, but I'd quite like there to be another sun on there. And then when I write on it, I can write different facts under different suns. And so there, so now I have a really nice design that I can add on my sun facts and think about what you might write. You might ask how far away the sun is and how old is the sun? What does the sun do for us? And so please look these things up. So I'm also going to show you a couple of other variations. Here's one that looks really complicated. So you could be more adventurous and do a bigger one. This one is looking at a solar eclipse. This is looking more at planets, but on this one, I put them on a spring like that. And I'm going to show you how to make that spring. So to make the spring, we need some strips of card. I've just used card, and I like to use a couple of different colours. So you take one strip here and you take another strip, put them at right angles, like that, and then put a little bit of glue there and stick that one on top of there. You need to fold these over, but do it in alternate colours. There we go. And a little more glue at the top. And so there I have a nice little spring to use. So what I'm going to do is I'm going to take a yellow circle. I'm going to put a little bit of glue on that end and a bit of glue on that end there to make an even more exciting design. Now you can use any variation of this. You can stick all sorts of things on it. And we don't mind if you stick a few satellites or even some rockets on it. I hope you've enjoyed this workshop and it's given you lots of ideas to make more things about space science using arts and craft techniques. Now, if you need more ideas, please look at the SunSpaceArt website where you will find lots more resources and ideas. There are Make It workshops and there are art and science workshops that you can do. If you want to see what other children have made, there are lots of ideas there as well. Please remember, using art and science together is a good way to learn. And I would like to say goodbye from me, Helen Schell, and goodbye from the SunSpaceArt team.